All right, so when we're doing this section, which is called writing functions of polynomials with given roots, in other words, what this is saying is, can you write me the equation where the answers came from? That's what it's asking you, okay? They're saying, look, I'm giving you the answers. Can you tell me where they came from? Okay? So, if these are my answers, then this is what I'm going to do. So let's try number 1 right here, okay? Let's get number 1 out of the way here. So one of my answers is -3, so I'm going to write x equals -3. Another answer is 4, so I'm going to write x equals 4. And my last answer is a 1, so x equals 1. So this is what you do to begin the problems. Now, the next step is you're supposed to set it equal to 0, meaning every little one of those equations, set them equal to 0. The way you do that is you move the number to where the x is. So in order to move the -3, the x equals -3, if I'm going to move that over, I'm going to add 3 to both sides. Okay, so it's going to look like this. X plus 3 equals 0. I mean, that's not hard to do, right? Just move it over. This other one, I'm going to subtract 4 on both sides. So I get x minus 4 equals 0. And the last one, if I move the 1 over, I get x minus 1 equals 0. So are we okay so far? I mean, not hard, right? First, you just write your answers. X equals this, x equals that, x equals that. And then you set it equal to 0 by moving the number over. Now, here's the hard part, I guess, if you want to call it that. You see all those 3 things that I have right there? X plus 3, x minus 4, x minus 1. We're going to do this. And they're going to want us to multiply this out. So that's the tough part. Okay, not that the multiplication is tough. It's just it's going to take a little bit of time. So that's what I'm going to do right now. Okay, I'm going to multiply this out. This is the longest part of the problem, but not necessarily a hard part of the problem. So here we go. Let's start with these 2 right here. Okay, we're going to ignore the x minus 1 for now. Let's just start with the x plus 3 and the x minus 4. So x times x is x squared. Okay, and x times -4 is -4x. And now I'm going to multiply the 3 with the x and the -4. So 3 times x is a positive 3x. And 3 times -4 is a -12. And then I'm going to write times x minus 1 at the end because that wasn't multiplied together yet. Now let me simplify that big old parenthesis right there. -4x plus 3x is a -x. So this is x squared minus x minus 12 times x minus 1. Now we're almost done. We just need to distribute again. Okay, we got to distribute again. So I'm going to get this x minus 1 on the right side, and I'm going to backward distribute. Okay, I'm going to go this way. All right. So x times x squared is x cubed. X times -x is -x squared. X times -12 is -12x. All right, so I did those. Let me multiply the -1 into those 3 terms. So it's going to go here, there, and there. And then we're pretty much done. We just got to simplify and we're finished. So -1 times x squared is -x squared. -1 times -x is a positive x. -1 times -12, positive 12. How are we doing? We okay with this so far? Just multiplying, okay? That's just what we're doing. Combine like terms, okay? So x cubed does not have a like term, so I'm just going to write x cubed. X squared does have a like term, so -x squared minus x squared. So this right here and this, these are like terms. So that's going to be -2x squared. And then -12x and positive x are like terms. So -12x plus x is -11x. And then that last number right here is 12. So look at this answer that I wrote. This is where those answers came from. Which is my right option? A, B, C, or D for number 1? It's C. And that's it. This is what this whole lesson is about. Okay? Notice you're not doing anything like incredibly crazy. You're just multiplying stuff. It looks a little off because, you can see all these like little rainbows going from one side to the other, right? But it's not supposed to be hard work. It's just sometimes takes a while to do it. Okay? So when you do like question number 2, you're going to write x equals -3, x equals 1, x equals -2, right, for number 2. And then you're just going to move them over. You'll get those terms on the left. You multiply them out. You'll get one of those answers. Okay? So that's how you're going to find those answers. So if you happen to see, so notice question 2 will be just like question 1. Question 3 will be just like question 1 and 2. Question 4 will be just like question 1, 2, and 3. But you might say, wait a minute, this one says multiplicity 3. What does it mean if they say multiplicity 3? Yeah, it's basically that number 3 times, right? So in other words, it's like them writing -5, -5, -5. That's the same thing. Okay, so if you happen to see that, multiplicity 3, just know you get to write it 3 times, and then just do what we did earlier. X equals -5, x equals -5, x equals -5. Do it 3 times. Write everything out properly, multiply, and you're done. Okay? Now, this is not the other one I was going to show you guys, because this one is just like the one I just did. It just has the same number 3 times. I want to show you guys one with an imaginary solution. Okay? Notice for number 5, as we're moving on, your 3 things will be x equals -2, x equals -5, and x equals 0. Right? For number 6, you would write x equals 5, x equals -5, x equals 3. And then you move your stuff over and multiply. Okay? But then they give us these. And this is the one we're gonna work on. Okay? We'll work on number 8 for the purpose of space here. So there's one thing you guys have to know. Okay? Imaginary numbers come in pairs. So if I say my answer is I, positive I, there's also a negative I. If I say my answer is -3i, there's also a positive 3i, okay? Anytime they mention an imaginary number, then there's always a pair of them, never just one. So you see how for number 8, there's an I and a -3i? So there should also be a -i and a positive 3i. There's actually 4 answers available for number 8. So this is the last example. Like I said, I didn't want to do too many because these take a while, so no need to do so many of these things. But notice how I had to add in 2 of them. Because it's imaginary, a positive I results in also a negative I. A -3i results in also a positive 3i. Okay? Now, I'm still going to do this the same way I did before. I'm going to say, all right, x equals I. Now, x equals -i. I'm going to kind of keep the ones that look similar together. And then x equals -3i. And x equals positive 3i. Now you might say, man, I'm going to have to multiply 4 different binomials. Well, the nice thing about the imaginary numbers is they tend to cancel themselves out. So we'll talk about that right now. Okay, I'm going to show you a nice little trick. So if I solve for these, I'm going to subtract I for the first one. You should get x minus I equals 0. For the next one, I should get x plus I equals 0. The third one, x plus 3i equals 0. And the last one, x minus 3i equals 0. Are we okay so far? Okay, we haven't multiplied yet, which is the part that people get scared with, but But I'm telling you, there's a nice little trick. Okay. So, all right, let's put all this stuff together. And then you're going to say, why do we have to do all of that multiplication? But trust me, not a big deal. There's actually a nice little trick to it, but let me write it out first. And then I'm going to show you the little trick up on top for the definition, okay? So I'm just setting it up. Now, we did this before. I don't know if you still remember this term, but do you guys remember me using the term conjugates? No? Okay, so conjugate is this. I think I heard someone say yes, but if someone says no, then let me remind you. If you have A plus BI, so X minus I or X plus 3I or whatever, the conjugate is the exact thing. Just the sign in the middle is opposite. The first one. This is called a conjugate. When you multiply two things that look identical, just that one of them is positive and one of them is negative. Okay? Now, why is this important? Because if you multiply this out, your result is basically this. It's A squared minus BI squared. That's it. You don't have to distribute. Just get your first term and square it. Get your last term and square it. Okay? And there should be a minus in between. That's your formula for this. Okay? So, I'm going to highlight something really quick. These are conjugates right here. And so are these. Notice how they look identical with each other except for the sign in the middle. So again, why is that important? Well, let's look at my x minus I, x plus I portion, the one that's highlighted in yellow. According to the formula, I just got to get my first term and square it and my last term and square it. My first term is an x. So I'm going to write x squared. My last term is an I, right? By the way, I got to put minus in here. My last term is an I, so that's I squared. And there you go. You just multiplied the yellow part. You just got that all done. Nice little trick. Okay? Now, what's I squared? Anybody remember? I squared. -1. So remember that for later. My next step, I'm going to do that. Now, let's move on to the next multiplication, which is the stuff in blue. So my first term is an x, right? There's an x plus 3i, x minus 3i. So the first term that I read is x. So I'm going to write x squared. Okay? My last term, let me put a minus here. My last term is a 3i. So I'm going to put 3i squared. And that's it. That's the multiplication. Right now we're just going to simplify. So x squared plus 1, remember, because I squared is a -1. So that's going to be x squared plus 1. And then the other side, x squared minus 3i squared is 9i squared. Now remember, I squared is a -1, so we're going to have to change that. So it's going to make that second parenthesis x squared plus 9. So let me write that out. Okay, because I squared is -1. So notice the first distributions, they weren't that hard. I just used a little formula, right, that told me take your first terms and square them, the last term and square them. And now I have binomials, and this should hopefully look very familiar to you, right? A binomial times a binomial, just distribute, and then we're going to be done, okay? So let's multiply these. So x squared times x squared is x to the 4th. X squared times 9 is 9x squared. Let's multiply the 1 now. So 1 times x squared, that's a positive x squared, and 1 times 9, that's a positive 9. If I combine my like terms, so there's the last step right here. I get x to the 4th plus 10x squared plus 9. Okay? Which would be C as well, right here. You only have 2 imaginary problems, okay? I just did one of them for you. So that means you just got to do number 7. That's going to be the other one, okay? The rest of them look like the ones that I did from before. All right? So I'm going to go ahead and stop here.